Hello and welcome to all. Greetings of the day, the authors and invited guests. Welcome to Technical Session 1E. Myself, Prashi, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastics, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2026, Bangkok, Thailand. The 11th edition of this conference is being organized in a hybrid mode, and the physical event will be held tomorrow in Bangkok, Thailand, and the virtual event is being held through Zoom from 9th to 11th April 2026. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for the question and answers. On the 9th minute, I will be raising a gentle reminder. There is another request to all the participants that you all stay connected to us till the closing remarks. If you have any queries or updates that you'd like, I request you to please write it down in the chat box given below. And just before we start our session, I would like to introduce you all to our chair for this session, Dr. Manoj Limchand Bangre. Dr. Manoj Limchand Bangre is the head of department and an associate professor of Srimati Kashyabai Navale College of Engineering, Pune, India. His research interests include cloud computing, task scheduling algorithms, and artificial intelligence. He is actively involved in advancing research and innovation in intelligent computing and optimization techniques. We welcome you to the session, sir. Before we move ahead, sir, would you like to say anything before we start our session today? Sir, I think we cannot hear you.
Yeah. Am I audible now?
Yes, sir, yes.
Yeah. Thank you for the organizer giving me this opportunity to work as a session chair for this today's presentation. And also all the best for the all participant. Do present your whatever the concept, idea, innovation you have, and stick to your time guidelines. Thank you. Yes.
Thank you so much, sir. With this, I would like to start along with our session today. I would like to call upon our first presenter for this session. Our first presenter is Kunal Day, presenting a paper on the title, A Compact Pairing-Based Signature Scheme for Isogeny Inspired Structures. I request you to kindly take over with your presentation, please. Sir Kunal Day.
Hello,
Yes, sir.
I'm audible?
Yes, sir, you're audible.
Yeah. So I'm sharing my slide.
Yes, sir.
Is it visible?
Yes, sir, it is visible now.
Okay. Okay. Shall I start?
Sir, please. Yes, please.
Okay. Thank you. So today I am going to present about our paper, which is accepted in ISID 2026, a compact pairing-based signature scheme from isogeny-inspired structures. So in this work, we have designed a compact signature scheme, which is based on bilinear pairing. And also we included isogeny structures in this paper. And so before that, I first introduced about digital signature. So a digital signature has three properties: authentication, integrity, and non-repudiation. And a digital signature, if you just see the syntax, it has three algorithms. First, key generation, where the signer generates his public key secret key pair. And next, the signature phase, where using the secret key and the message, the signer generates a signature. And verification means anyone can verify the signature using the public key of the signer. So in classical cryptography, the well-known digital signatures are RSA or L-Gamal type of signatures. RSA is based on integer factorization problem, and discrete logarithm, and L-Gamal is based on discrete logarithm problem. Then I'm going to introduce about bilinear pairing. A bilinear pairing is a function from G1 cross G2 to GT. We have three cyclic group mainly, of prime order P. And it should satisfy three properties. First property is bilinearity, E of AP and BQ. If you give two inputs, you will have EPQ to the power AB. And it satisfy also EPQ not equals to 1. And it should be efficient computability. This condition, these three conditions should satisfy a bilinear pairing. And the advantages of this bilinear pairing are it will generate compact signature and efficient verification. Now, in isogeny-based structures, we need to first state what is isogeny. The isogeny is a surjective group morphism for between an elliptic curve to elliptic curve, and this function may not be invertible. If we have an isogeny between two elliptic curves, we will say that these two curves are isogenous. And isogeny from same elliptic curve to same elliptic curve is called an endomorphism. And the advantage of this isogeny-based structure is this is compact representation and efficient group operations. So this is our proposed signature scheme. In the setup phase, as I have mentioned earlier, in signature scheme, we have three sub-algorithms: setup, signature, and verification. In the setup phase, the signer will generate his public key and secret key. For that, signer first chooses two primes, P and Q, such that P is equals to 12Q minus 1, and E be an elliptic curves. And we will define two groups, G1, which is a cyclic group of order Q, and G2 can be any subgroup of AP square of order Q. And we will define a bilinear pairing from G1 cross G1 to G2. And here we'll choose a secret isogeny, which is psi of degree L, or of order L. And the public key is the image of this isogeny on this X, the generator of this G1, which is Z, and in isogeny computation, L times psi X, which is W. So in secret key, we have only one isogeny, and in public key, we have 2 points, Z and W. This is signature generation. So first, the signer will choose random element from ZQ star K and one element from G1, which is Y. First, it computes a bilinear pairing, E of psi Y Z whole to the power K. And then it will compute a hash function, where H is the hash function from an arbitrary bit string to G1. So it will choose a message M and compute this hash function and output V. And again, a point on this elliptic curve U, which is K times psi Y plus LV. And output the signature as UZ. So verification is very, actually, this is very easy. So the verifier has to just check, verifier has no public key and the signature. So here public key has ZW and signature has UV. So verifier will just verify E of UZ into E of V minus W is equals to R naught, and it will accept this R if this hash of MR equals to V. So actually, our bilinear pairing ensures our correctness of this protocol, and isogeny structures ensures compactness of this protocol. That's why our scheme is compact. So we'll prove the security of this scheme, which is UFCMA, unforgeability under chosen message attack, in the random oracle model. And the security is based on the hardness of isogeny problem. So suppose you are given two elliptic curves. You cannot find the isogeny between these two elliptic curves. This is very hard problem, which is believed to be hard in cryptography community. And the proof structure, we have proved this theorem using game-based reduction. And the idea is we replace real signature and hash output with simulated values, which is random values. And we will, at the end, we prove that the adversary which is in the UFCMA game, the advantage is very negligible. So this is the structure of the security statement. And next, the efficiency. So as I mentioned, our signature scheme is very compact. So in our computation, we have used one pairing and one exponentiation. And for verification, we have used two pairing computation. So our public key cost will be 2 log p. So we need 2 log p bits, and for signature, we need 4 log p bits. And for experimental result, for 128-bit security, where we have taken P as 256-bit prime, where secret size is 254 bits, public key size is 518 bits, and signature size is 514 bits. And for performance, the key generation takes 0.0018 second, and signature signing algorithm and verification algorithm are also very efficient. So in future work, so in this work, we have just designed a very basic digital signature scheme using pairing and isogeny. So in future work, we can optimize them using fast pairing computation or efficient isogeny evaluation. And it has numerous applications in IoT, blockchain, or lightweight cryptography. And also, we'll try to extend this work to post-quantum secure variants. Thank you. Thank you so much.
Yes. Thank you for the presentation. Can you just go to the first slide?
Yes.
Okay. Okay. What is the motivation behind this your work?
So the motivation is the already defined digital signatures are not that much efficient. So some digital signatures take a lot of memory, or some digital signature takes a lot of time to implement the algorithms. So here we try to build a digital signature using pairing and isogeny. So isogeny has compact structure, and pairing has fast verification. So we just try to combine these two structures.
So what is the exact role of this isogamy inspired structure?
So here you can see in our protocol. So there, here the secret key is kind of secret isogeny. So suppose you are given Z is psi of X. If you are given X, so you cannot determine the isogeny. This is the hard problem believed in isogeny-based cryptography. So if you are given two image or two elliptic curves, you cannot just derive the isogeny between these two elliptic curves. So our protocol is based on this hard problem.
Okay, okay. Got it. Yes, thank you.
Yeah, thank you so much.
Thank you so much for your presentation, sir.
Thank you.
Now I would like to call upon our next presenter for this session, Sanjida Karim Pauli, presenting a paper on the title a comparative study of machine learning models for early diabetes risk prediction. I request you to kindly take over with your presentation, please.
Yes, please start.
Ms. Sanjita. Okay. Looks like that we don't have her right here right now. I'd like to call upon our next presenter, Sir Nadeem Sayed, presenting a paper on the title, A Probabilistic Pipeline for Forecasting Cryptographic Lifetimes Under Classical and Quantum Threats. I request you to kindly take over with your presentation, please.
Hello, how do you hear me?
Yes, we can hear you.
Yes.
Okay.
Okay. Okay. Please let me know when to start.
You can start, sir.
Thank you. Hi, everyone. My name is Nadeem Saeed. I'm a master's student at the University of Waterloo, and today I'll be presenting our paper, A Probabilistic Pipeline for Forecasting Cryptographic Lifetimes Under Classical and Quantum Threats, coming out of the University of Waterloo with the following sponsors shown on the screen. A huge thanks to all of our co-authors and especially our first author, Jose Rosas Bustos. So I'd like to start off with something everyone in this room can relate to, which is cryptography. Cryptography is already built in our daily life, into our daily life. When you log into your bank account, when you send a message, when you buy something online, or when you scan a boarding pass at the airport, you are relying on cryptographic systems. Those systems do not stay equally strong forever. Their effective security changes over time because of better computing power, improved algorithms, and the possibility of quantum attacks as quantum computers in today's age advance. That is why this becomes a governance problem, not just a technical one. So organizations need to decide when a cryptographic system is no longer safe, when to start a migration, and how much time to reserve before the risk becomes unacceptable. So this is a really good example of why cryptographic lifetime matters in practice. In a harvest now, decrypt later scenario, an attacker steals encrypted data today, stores it for years, waits for future advancements in computing, such as harnessing the power of a quantum computer, for example, and only decrypts it then. So for long-lived sensitive data, such as governmental data, migration timing is not just a future problem, it is a present-day decision, in fact, and that is why this framework we're proposing is very vital today. So the goal of this work is to provide an auditable tool for forecasting cryptographic lifetimes. This framework is designed to support three audiences at once: industry practitioners, researchers, and decision makers. It provides them with key insights on migration timing. This will also turn uncertainty into something traceable and actionable and tangible. And this framework produces defensible planning guidance that can be reviewed and, more importantly, updated as external factors evolve over time. So this slide is the heart of our paper or our framework that we're proposing. It showcases the three stages of the pipeline. Stage one asks, where are we today? How fast might our security erode? Stage two asks, as new evidence comes in, how should our understanding of risk change? This matters because real-world signals could get very messy, and we do not want weak evidence to cause an overreaction. And then this comes to stage three, which is based on that updated risk picture. When should we act, basically? This is where the framework becomes operational. It produces timing slack, start by windows, and clearer priorities. So the framework as a whole turns cryptographic uncertainty into structured decision processes. So this is the core equation of this framework, and I'd like to spend some time to define every part of it. So first, S of t is the general security margin at time t for a specific cryptographic mechanism in a specific asset context. By security margin, I mean the remaining safety headroom before that system drops below an unacceptable level. This, of course, could be measured in different ways across industries or entities, for example, bits of work or an internal policy score. The important requirement is that the scale should be consistent and that lower values mean less security or that the system is getting less safe. So secondly, S naught is the starting point today, the current baseline margin. K is our erosion or decay rate. It tells us how quickly a cryptographic or security system shrinks over time. A larger K means a faster decay, and a smaller K means a slower decay. And then the X is our threshold margin, which is the minimum acceptable level set by a policy for a specific asset class. In other words, X is a floor or a constant that you do not want to dip under. So this slide applies the equation directly. We use S naught as 100, and we use K as 0.02 as the assumed erosion rate, and X equals 50 as the minimum threshold. And the blue curve shows the security gradually declining over time, and the red dash line shows where the system no longer becomes safe when it crosses that point. A practical way to understand this is imagine a TLS or VPN configuration that works perfectly today, but whose security headroom shrinks over time. The value of the model here is that it turns that gradual decline into a visible migration decision timeline. So now that I've explained stage 1, which is the initial security margin and the decay rate, I want to explain stage 2 and 3. Stage 2 exists because we do not observe cryptographic risk directly in practice. We actually observe signals about how it might be incomplete or how we could observe new research or external factors, for instance. To make sense of these signals that we get, we use hidden Markov models or HMMs. And an HMM is a model where the true condition of the system is hidden, but we can infer it from the observations we do see over time. So in our case, the hidden condition is the risk state of the system, and the HMM estimates which hidden state the system is most likely in. And our framework defines 3 states: highly secure, moderately secure, and at risk. And the key output here, lastly, is the posterior probabilities. That simply means that after looking at all the evidence we have so far, we get a probability distribution across the states. And that is important because it prevents us from overreacting to one weak signal specifically and gives us a much more stable weighted basis for updating migration decisions over time. So stage 3 is where the framework becomes an actual decision tool. The question here is no longer how security is changing, but the question becomes, is waiting still valuable or is action immediately urgent, essentially? And the key parameter here is the timing slack V of t, which is thought of as the compact measure of how much room we still have before a migration should happen. And this could include the time needed to perform the migration itself, of course, because many systems could have longer migrations that are needed. And timing slack V of t also depends on uncertainty. So if migration to a new security system is hard, then the value of waiting drops and the start by window shifts earlier, so hence requiring an earlier migration. So this paper runs the following case study on 2 crypto algorithms: RSA 2048, which is one of the most widely used asymmetric public key cryptographic algorithms today, and MLChem 768, which is the post-quantum replacement candidate we are proposing, or the case study proposes. And the reason these 2 were chosen is that the paper wanted to model a realistic migration problem, which is moving from a classical algorithm to a NIST-certified PQC, or post-quantum computing algorithm, which is, of course, super valuable in today's quantum era. The numbers on the slide are assumed are the initial security levels. That is 128 for RSA and 160 for MLChem, and the threshold is fixed at 64. So the results here show that migration timing changes a lot on the assumptions we make. The purple horizontal line is the policy threshold, which is set at 64. Once a curve falls to that line, that legacy system, such as RSA in this case, is no longer comfortably above the minimum acceptable security level for that asset. And the red dashed line is MLChem, and the three solid curves are RSA under early, which we define to be 10 years crossing the threshold, baseline, and late quantum arrival scenarios. And the idea here is that the legacy RSA curve changes dramatically depending on the scenario, while ML-Chem curve remains comfortably above the threshold in this illustration. So overall, the main contribution of this paper is practical forecasting framework for cryptographic lifetimes. It helps decision makers see when an asset needs attention first, when a migration should begin, and how those timelines change as assumptions and evidence or external factors even change. And the overarching message I want to leave with all of you is that cryptographic obsolescence should not be treated as a future surprise. It should be monitored, forecasted properly, and managed as part of every organization's security arsenal. Thank you very much.
Yes, thank you for the presentation. What is exactly the objective of this work?
Objective of this work is to provide an actionable, tangible pipeline or a framework that helps organizations forecast cryptographic threats when security systems become obsolete and when's the right time to perform migrations to protect certain organizations' security.
Yes. So as per the result graph which you have shown on your x-axis, can you just go to the slide? Yeah. On this x-axis, there is time in years you are mentioning. So this graph is a predictive analysis?
Correct. Correct. It is a predictive analysis for comparing RSA 2048 and MLChem, which is a PQC NIST certified algorithm.
Okay, so as per this result, so as the number of years get increased, the security levels in bits also it also get decreased.
That is correct.
Okay, so what exactly the conclusion of this result?
The conclusion is that current classical algorithms such as RSA are decaying faster in time than proposed new algorithms such as Kyber or MLChem, in other words, hence calling for a migration plan for organizations and governmental entities to migrate to a post-quantum NIST certified algorithm because it's going to become obsolete.
Okay, yeah, thank you.
Thank you.
Thank you so much for your presentation.
Thank you.
Now I would like to call upon our next presenter for this session, Ronald S. Cordova, presenting a paper on the title AI-Driven Sentiment Analysis Framework for Optimizing Digital Marketing Promotions. I request you to kindly take over with your presentation, please.
Yes, thank you, Ms. Prashi, and thank you also, Dr. Manoj, for moderating this one. Let me share first my screen. And good morning, everyone. I still cannot share. Okay, now it's fine. Wait, just please wait. Okay. Okay, wait. Oh, sorry. Okay, can you see now my screen and am I audible?
Yes, sir, we can see your screen and you're audible.
Yes, thank you, and good morning once again, and thank you for this conference. I am Dr. Ronald Cordova from Gulf College, Oman, together with my co-authors, Dr. Rowena Sibayan, Dr. Hazel Tagalog, and Dr. Rololin Mata. Today, I'll share our AI-driven sentiment analysis framework for improving digital marketing promotions. Because of time limit, I will try to explain my best and to stick with the time. The simple idea is this. Customers already tell us what they feel online, but the feedback is too large and too unorganized to read manually, or our goal is to turn that feedback into clear marketing decisions. And I'll cover five parts, the problem, the objectives, key points from the literature, the 10-step framework and methodology, and finally, the main implications and recommendations. Digital marketing generates massive customer comments from reviews and social media. Traditional metrics like clicks and views are useful, but they don't always show how customers truly feel. So this creates a gap. Campaigns may look fine on dashboards while customers are actually unhappy or losing trust. So the paper addresses this gap by using AI to capture sentiment at scale and in near real time. So the paper has this clear objectives. First is to explain how AI-based sentiment analysis can support marketing decisions and propose an end-to-end framework that links data, modeling, and marketing action in one flow. From the literature, we have three ideas that stand out. Sentiment analysis helps track brand perception and customer satisfaction. NLP and AI make it possible to analyze feedback from many channels at once. And the third one is better sentiment signals can improve targeting and campaign performance. So the paper also summarizes the three model families. As you can see, lexicon-based, machine learning, and deep learning transformers. And I want to thank also the reviewers of this paper. Just a short background, this paper was originally submitted to ICTIS USA, but because of this untoward incidents that it's happening now, it was referred to ICTIS Thailand, and I want to give my appreciation together with my co-authors and on behalf of my co-authors to the reviewers, because originally this is a 7-step framework. Then the reviewers of this paper um, suggested that I add insights and decision making and multimodal sentiment extension and empirical validation and comparative evaluation. So step 1 to 5, build the sentiment engine, collect data, clean it, extract features, select models, and train. And step 6 to 10 turns outputs into decisions, classify sentiment, scale the pipeline, generate insights, apply them to promotions, and validate results. In short, first we build the model, then we make it useful for marketing. So step 1 is collecting feedback from social media. As we can see nowadays, a lot of feedback coming from social media, online reviews, and we can find a lot of these reviews in Google and campaign channels. So the paper also recommends collecting contexts like timestamps, language tags, emojis, and campaign IDs, because these details help explain what customers mean and when the message matters. So step 2 is about cleaning the data. Online text is noisy, dense, slang, hashtags, spelling errors, and links. So we normalize and tokenize the text. Okay. And step 3 to 5 focus on the models and training. So the paper groups models into 3 families: lexicon tools for fast baselines, machine learning for structured learning with label data, and transformers for stronger context understanding. And then for features, we can use TF-IDF for embeddings like Word2Vec and BERT embeddings. Those who are into these algorithms are familiar. And the message here is good representation plus good training is what produces reliable sentiment outputs for sentiment analysis. And step 6 is for classification. Often we could classify 3 sentiments, often positive, neutral, or negative, and then we do the evaluation. So the framework evaluates using accuracy, precision, recall, and F1 score. It also notes difficult cases like sarcasm and ambiguous language and suggests fine-tuning transformers and adding human review for low confidence results. And step 7 is making the system practical. Marketing teams need timely insights, not reports that arrive too late. So the paper recommends streaming or micro batch pipelines, distributed processing, and elastic scaling. And for the ethics, so this paper emphasizes also responsible use. Key points are privacy protection, bias reduction, and transparency in AI-assisted decisions. So in practice, the framework aims to deliver cleaner sentiment signals from large volumes of feedback and translate them into marketing action. So this supports better personalization, faster response to negative sentiment, and more data-informed promotion decisions. So the paper recommends improving multilingual support to handle different languages, handling sarcasm better, using scalable pipelines, and adding explainable AI so teams understand why model predicts a sentiment. So a key next step is to validate the framework with real campaign case studies and real organization datasets. And to close this work proposes a simple end-to-end framework that connects AI sentiment analysis to real marketing decisions. I would like to leave you with this one. We turn raw or unstructured customer feedback into clear, timely promotion decisions. The 10-step framework bridges data models, deployment, and marketing actions. And I would like to acknowledge our sponsor for this one, this paper. This research is sponsored by the Ministry of Higher Education, Research and Innovation of the Sultanate of Oman under the Block Funding Program. And also, I would like to thank my institution, Gulf College, and thank you for listening, everyone. And I'm happy to take your questions.
Yes, thank you.
Yes, thank you,
For the
doctor.
presentation. Am I audible now?
Yes, doctor.
Yes. So you have mentioned the sentiment analysis. So what is the
Yes,
roles of false positive, false negative parameters?
This false positive and false negative parameters, because sometimes the problem with the comments and suggestions or the feedback is they are telling that it is good, but and then after that one, there is another comment which contradicts the first positive comment, doctor.
Yes. Okay.
So we don't want to confuse
Yes.
because yes, doctor, if it's really a positive comment, it should be like a positive comment that it's good, it's nice, like that. Okay, but in the end, after the statement, that one doctor, it will say that it should be better like this, or it should, for example, for the McDonald's, they are telling that the burger is nice, but the place is it's not convenient.
Okay. Thank you, doctor. Yes.
Yes, thank you. Thank you so much, doctor, and thank you, everyone. I'll stop sharing. Thank you.
Thank you so much, sir, for your presentation. Now I would like to call upon our next presenter for this session, Kotapati Venkata Pavan presenting a paper on the title Detecting Fake Products with Blockchain Technology. I request you to kindly take over with your presentation, please. Sir Pavan.
Yes, ma'am. Yes, I am.
Yes, sir.
Am I
Kindly
audible?
take it. Yes, sir, you're audible.
Uh, actually, wait, wait a minute. Could you wait for a minute, ma'am?
Yes, sir.
Nagarjuna, please. My friend Nagarjuna has my PPT, ma'am. He is going to present. We all are one team. Is that okay?
Okay. Somebody else is presenting for you.
He
Done.
he and I am we all are in one team.
Okay, sir. Okay. You can start presenting.
Okay.
So do we have any problems with the presentation?
Yes, ma'am. 2 minutes. Can ma'am, is my screen is visible to
Yes, ma'am, your
you,
screen
ma'am?
is visible. I just request you to kindly open the, kindly click on enable editing.
Ma'am,
Actually, you're presenting us the Zoom space right now, ma'am. What you can do is open the presentation, click on enable editing, go to F5, present it, and you can directly share the screen of presentation to us.
good morning, ma'am.
Is there
Our
any
project,
network issue?
yes, ma'am. We are having network issue here, ma'am.
Would you like to take some time and then present your presentation? Meanwhile, I can take the other person if that is comfortable for you.
Okay, ma'am.
Okay, I request you to kindly take some time. Meanwhile, I'll just call upon the next presenter for our session, if that is convenient for you.
Ma'am, we are having network issue. Can you give please time with 5 minutes, ma'am?
Please, ma'am. I'll take the other presenter meanwhile. Okay.
Okay, ma'am. Thank you.
Thank you so much. Okay. Now, as we have a error at the end with the network, I'll try to call upon our next presenter for this meeting. Our next presenter is Ms. Dag Zamani, presenting a paper on the title Network Security Evolution through Artificial Intelligence and Machine Learning, Architecture Models and Experimental Evaluation. I request you to kindly take over with your presentation, please, sir. Sir Zamani.
Chopra. Yeah,
Sir? So we cannot hear you right now.
So you couldn't hear the video's audio?
No, we could not hear anything. Now we can hear you, sir.
Okay, give me 1 second to try again.
Yes.
So is my screen shared to the meeting?
Yes, we can see your screen, sir.
All right, so let me share the audio.
Again, we cannot hear you.
I'm trying to, let me see if it works now.
Okay.
And the machine learning.
Yeah, now we can hear it. So,
hello, everyone. My name is Dr. Mazdak Zamani from State University of New York System, specifically from Empire State University. Today, I will be presenting our work on network security evolution through artificial intelligence and machine learning, where we explore how AI-driven approaches can significantly improve cybersecurity performance compared to traditional methods. All right, so modern networks such as cloud systems, IoT environments, and 5G have dramatically increased both complexity and attack surfaces. Traditional security methods like rule-based systems and signature detection struggle against advanced threats such as zero-day exploits and polymorphic malware. In this work, we propose a hybrid AI framework that combines supervised, unsupervised, and deep learning models. Our results show that AI-driven systems outperform traditional approaches, particularly in detecting unknown and evasive attacks. We also highlight future directions, including adversarial resilience and self-healing security systems. Traditional networks, traditional network security relies heavily on predefined rules and known attack signatures. While effective for known threats, these methods fail when facing new or evolving attacks, especially encrypted or polymorphic attacks. Static firewall rules also lack adaptability. They depend on manual updates and cannot respond dynamically to changing attack behaviors. This feature of them is one of the main motivation for integrating AI into cybersecurity. To address these limitations, we propose an AI-driven architecture that replaces static rules with adaptive machine learning models. The system proposes network data in several stages. First, data is collected from traffic, logs, and sensors. Then features are engineered and transformed into structured inputs. Next, a detection engine analyzes behavior using machine learning models. Threat intelligence correlates findings with known patterns. Finally, automated responses are triggered, such as blocking threats or isolating systems. This enables continuous learning and adaptation to evolve cyber threats. AI models in the structure. Our framework combines three types of learning. First, supervised learning, which uses labeled data to classify traffic as benign or malicious. Second, supervised anomaly detection, which identifies unknown threats by detecting deviations from normal behavior, often using auto encoders. Third, sequential deep learning, specifically LSTM models, which capture time-based patterns and detect complex multi-stage attacks. By combining these approaches, we achieve a more robust and intelligent detection system. Experimental setup. To evaluate our approach, we used two well-known databases that you can see in this slide, both of which include realistic and diverse attack scenarios. We extracted 78 network flow features, including packet timing, flow duration, protocol behavior, and traffic volume. These features allow us to model both statistical and behavioral characteristics of network traffic, ensuring a comprehensive evaluation. Training and evaluation. Our training setup used an 80/20 train test split with Adam optimizer and 50 training on GPU-enabled hardware. To evaluate performance, we use multiple metrics: precision, recall, F1 score, and ROC. This combination ensures we assess not only accuracy, but also the balance between detecting attack and minimizing false alarms. Results and performance analysis. Our results show that the hybrid AI framework significantly outperforms traditional intrusion detection systems. For example, traditional signature-based systems achieved about 87% accuracy, while our hybrid model reached 97.4% accuracy and nearly 98% F1 score. We also observed a 32% reduction in false positive, which helps reduce alert fatigue. Importantly, the system is effective at detecting zero-day attacks and insider threats. This success comes from combining multiple strengths: supervised learning for known threats, anomaly detection for unknown threats, and deep learning for temporal patterns. In conclusion, we introduced a hybrid AI-driven framework that significantly improves network security performance. This approach enables proactive and adaptive threat detection, moving cybersecurity from a reactive model toward autonomous systems. However, challenges remain, including adversarial attacks and computational cost. Future work will focus on federated learning for scalability and explainable AI to improve transparency and trust. So I guess that was it. And thank you for your attention. I'll be happy to take any question, and you can see my email and information in the first slide. And I will be happy if also you send me an email. I will be happy to answer your question, or if you have, I will be also happy to have
if there is any question, I will be happy to answer now.
Am I audible?
Yeah, you are.
Yes. Actually, due to some network issue, for some couple of minutes, I was not able to hear you. Can you just go to the conclusion again, Miss Slide?
Um,
Hello, everyone. My name
Actually, I'm not able to see conclusion slide. Maybe
Sir, I
due
request
to
you
my
to
yeah,
kindly
network.
present
yeah,
this.
because it comes from a video, so I need to.
No, sir, you're not presenting right now, actually.
I think so.
I request you to kindly share this.
अरे माझी हे मीटिंग चालू आहे. अच्छा, त्यामुळे ते फोन उचलला. मला माहिती फोन कशासाठी आला असणार आहे. हे यांचा कार्यक्रमच असा आहे. हे घेऊ मी बोल नाही तेवढंच टोप क्या आहे कॅप आणि ते तेवढं हा बस बस.
Yes, sir, now we can see the conclusion.
Yeah, now I can see. Just a minute. So, reactive difference. Okay, you as per this your work you have some AI driven intelligent threat detection system. It has been implemented, right?
Yeah.
Okay. So what is the key contribution that you exactly have done for this work? Because here actually the strong performance gain over the traditional rule-based system. So this indicates some performance parameter you have handled. And another one is the enable proactive, adaptive, and intelligent threat detection. So what is exactly the key contribution?
Yeah, the rate of the detection that has increased from 80 something to 98.
So, okay. I think there's some network issue at Dr. Manoj's work. Okay, now he's here. So, are you happy with the answer?
Yes, yes.
Okay.
Please.
For sure. Okay. So now I would like to call upon again Sir Pawan. I request you to kindly start ahead with your presentation, sir. Sir Pawan, are we ready with the presentation?
Yes, ma'am. I'm
Okay. So we cannot hear
Our
you.
project is based on the detection of the fake product with blockchain technology. Okay, here is an introduction. For nowadays, there are so many counterfeit products growing they are copying it like a first copy, second copy on that. So we like to reduce that. We like to reduce that measure countermeasures by using the blockchain technology in an online platform. Uh, and these are the abstracts and keywords. It is a huge rate for the so many businesses for small and medium sized businesses, and also it interrupts the safety for the consumers and their brand trust, and also the businesses profits also will get less. So we use a blockchain technology for small and medium business purposes. We use AES encryption and biometric and OTP authenticate to create a secure and decentralized product verification. And each of them will identify is it a fake or not. This is our problem statement. Which are counterfeit products are rapidly increasing globally by day, and also it will damage their product and brand reputation also, and it will decrease their profits. Our main objectives are to prevent the counterfeit products by using the SMP supply chains, and ensure that a product authentication should be encrypted by using blockchain technology. It should provide fast and scalable verification without a damaged recovery. And it strengthens the consumer trust and their brand protection and their valuable also. And we use a decentralized and tamper-proof solution. Traditional anti-counterfeit measures like RFID tags and centralized databases are now outdated, but still we are updated in AI and blockchain technology. It record when they are buying a product, it records their process, and they will give you the major QR codes to them, and it will create a immutable and distributed ledger, significantly reducing the chance of data manipulation. In nowadays, we have gone through so many studies and published research papers. There are a rapid adaptation in blockchain technology in anti-counterfeiting with a successful pilot implementation across the sectors. Academic, industry, and the literature confirm that blockchain-based systems are better security and traceability than traditional solutions. So we use a real-time authentication and consumer trust. These we have taken survey from all these authors, and we have taken relevance. We have used these technologies like blockchain, encryption, authentication like biometric and OTP based, and product identity by the unique QR code, and they can't recover the QR algorithm, and it's a one-time usability those QR codes, and these are the existing systems like RFID tags and barcodes, and they can fake it easily nowadays, and labels and tags they are counterfeiting easily. So we propose a fake product system which is designed and with a secure and scalable distributed and 3-layer model. The first layer is gonna take by the manufacturer interface. It uses the HTML and CSS and JavaScript on what they are buying and how, and the backend will take over the manufacturers and small businesses. And after they submit their information, the system automatically generates a unique QR code using blockchain technology. We will store data in blockchain-based systems, and this is our methodology. We have taken there are so many differences in between a customer to customer and timestamps or manufacturer data triggers in warning about authenticity, and we have taken so much hard work. The implementation of the fake product detection using the blockchain technology is a smooth and secure workflow. First, a manufacturer registers a product, and the product data will safely stored in a blockchain technology, but a short form of it. But it will be so much useful for us, and it will generate a QR code which is printed on the product, and he has to scan it. After he logs it, the customer scans the QR code, and he gets the verification OTP, and then only he can identify or is it a real output. This is our result and outputs we have gotten. This is the project view. The FPSMF framework helps us small and medium business sized business fight counterfeit the products. It will fight the counterfeit products using the secured and decentralized system. We use a hyperledger blockchain and AES encryption and biometric OTP authentication to assign the product as a unique identity. Product data like manufacturing, shipping, and location is stored immutably, and the verification will be come faster, and the consumer will get the product safely and securely. This is our conclusion. We would like to mostly reduce our fake product detection, fake products in our daily life. That's all. Thank you. Is there any queries you would like to ask? You can. Hello.
Thank you for your presentation, sir.
Oh, thank you.
Yes. What was your motivation for this idea using blockchain technology?
Actually, when I ordered from a website, I got an
Uh,
hello, sir. Hello.
so we could not
Is it
hear
okay?
you.
Hello.
Due to network
Am I
glitch.
audible?
Yeah, you are audible right now. We could not hear the answer, sir.
Yeah.
I got a counterfeit product from the website. I have booked, and when I ask them, it's a real one. They say so. I would like. I have gone through so much because of that. So that's why I take it personally, and I have designed it.
Okay. But this idea provide online real-time tracking, or after only receiving the product, it can just identify whether it is genuine or fake or some kind.
After receiving product, he can check it. Is it a real or not?
Okay.
Bye.
Okay. Thank you.
Thank you.
Thank you so much for your presentation, sir. Now I would like to call upon our next presenter for this session. So Vedant Maheshwari presenting a paper on the title Novel Spectral Jailbreak Classifier System and a Stability Metric to Assess and Identify the Complex Nonlinear Prompt Dynamics in Large Language Model Jailbreak Attempts. I request you to kindly take over with your presentation, please. So Vedant.
Hello, am I audible?
Yes, sir, you're audible.
Yeah, I'll start sharing my screen. Is my screen visible?
Yes, your screen is visible now.
Yeah, actually, I'm facing some problem with. Okay, yeah, I'll start. So my research is about novel spectral jailbreak classifier system use and a dynamic stability metric to assess LLM prompt dynamics. So I'm a student of in Amrita School, Amrita Vidyapith, Coimbatore. So what exactly is a dynamical system? So large language models rely on a transformer architecture which are highly complex and nonlinear. They transform input sequence token by token across layers, so continuously introducing nonlinearity because of the nonlinear activation functions. So recent research show that adversarial prompts exhibit specific patterns like increased logic oscillations, anomalies, and anonymous hidden state rotation, entropy fluctuations. So what we did is we introduced, or we actually combined Koopman operator theory, which is from a mechanical or mechanistic approach used into as a nonlinear dynamics approach towards the large language model. As I said, it can be thought of as a really long sequence of nonlinear uh, activation functions and nonlinear operation happening on a token dynamic. So what exactly is Coupon approach? So instead of looking at the complex state X, we map the system to a much larger infinite dimensional lifted space of the observables. So this was proved by Sir Koopman or Dr. Koopman in 1930s. It's a very old theory, but really holds true till this. It really holds true till today. In this massive new space, the chaotic transition from time step t to t+1 becomes strictly linear. Because of the evolution is linear, we can use a linear matrix, a Koopman operator, to represent it. So the key lies in the Koopman operator k, which actually linearizes it in the lifted observable space, not in the original space. Lifted observable space is made up of a set of or dictionary of functions which can be applied on the token dynamic or token space of that. This allows standard linear algebra to complex nonlinear behavior. So just for the formulation, if a dynamical system x of t+1 is equal to f of x with state space x, then the Koopman operator k acts on the observable scalar observable space, which maps from k from G, which is x space, to C space, which is a lifted observable space. So it's basically applying k, the Koopman operator on the observable g of x is actually equal to the applying getting the next state in the observable space. So it's a linear transformation done using Koopman operator. So spectral decomposer k, since k is linear, we can extract its intrinsic properties such as eigenvalues and eigenvectors. So eigenvectors is said to be eigenfunctions because it's in functional space. So how and why we apply Koopman to LLM prompts? Think of a prompt as a dynamic layer. As I said, prompt and a transformer as a dynamical system. So say prompt introduce contractive, predictable trajectories flowing smoothly, and jailbreak prompts introduce semantic conflicts, injecting energy that causes systems hidden states to oscillate and become highly unstable. So mapping these layer by layer dynamics using Koopman operator, we can actually see a global behavioral change in the prompt trajectory. The core advantage, it translates the black box non-linear hidden state transition into a linearized interpretable coordinate system, where the prompt stability can be mathematically analyzed and measured as a concrete risk score. So this is the model or the methodology which we incurred to approximate the Koopman operator K and carry out our further research. So we used SRKE, which is sparsely regularized Koopman autoencoder. So instead of giving our own functions, a set of functions, we utilize autoencoder, which can learn the nonlinear mapping using encoder and decoder architecture. And after the encoder architecture in the latent space, which is the lifted observable space, we calculate the Koopman operator using three formulations of this optimization formula. Given the trajectory pair x and x of t+1, so it works on the shifted observables. So if I have 1 to 5 observables, so x of t will be 1 to 4 and x of t+1 will be 2 to 5. So we want to predict the next state, as in predict the next set of transitions. So we optimize the following loss function, which is LRecon, predict, sparsity, and regularization. So recon is measure how well the autoencoder reconstruct the state, which is actually normal autoencoder loss function. LPRED is measure how accurately K predicts the next state. So it's basically K times x of t should be equal to K of should be equal to x of t+1, which we compare with the original set we have. Sparsity enforced sparsity because it's a sparsely regularized. So basically L1 norm and L regularization, regularize the Koopman operator to not have an exploding eigenvalue problem. So the proposed spectral risk score. So after we get K, we spectrally decompose it and get eigenvalues of it in order to make a risk score for every prompt, each and every prompt. So for each and every prompt, we can calculate these 4 set of sub risk scores and combine it with some weighting, some weight, and get a actual risk score, the whole risk score. So I'll go through it briefly. So it's weighted instability. It measures how far it is from the stability boundary. So here the stability boundary is defined as 1 because a system is stable if it's 1. It's contractive. Or it oscillates inward if it's less than 1, and explodes outwards if it's more than 1. So this is how we define the stability metrics. Oscillation coherence is actually the argument of the lambda, which is because many of the it's not a symmetric matrix. We cannot guarantee that the matrix would be symmetric, the K matrix. So it will give us iota or no non-linear system would give us the arguments as lambda of j, which is sine theta and cos theta, which we combine as this what is written here, and helps us differentiate between highly coordinated coherent jailbreak oscillations and standard benign complexities. Next is spectral entropy ratio, which is entropy of the system. This is how we distinguish between peak eigenvalue spectra and from the normal spectra. This acts as a critical filter for reducing false positives and the trajectory divergence. This measures how far it is going from the initial trajectory, following upon the next set of trajectories. So our experimental setup was, so we took 500 prompts from ADB bench. It's a benchmark dataset, and 500 benign prompts, safe prompts from NeuroAlchemy benign dataset. Both datasets are used for training the dynamic model which was used was Microsoft 5.2. Dimensions of the model are 2560 in the hidden space, and the Köppen latent dimension was 32. These are the training specifications and hardware. So this is our result. So as you can see, we have precision of 91, recall of 89, and F1 of 90, which is fairly balanced score. And we actually optimized the weights, which I talked about, alphas, using Bayesian optimization, and we got a most optimum weighting score in order to maximize FN score. We can maximize based on different arguments such as recall and precision, depending on the business needs. So there are few graphs which we can see, plots actually. These are the representations. So blue is the safe prompt, trajectory over the transformer layers, and the risk metric is in the y-axis, and we can see there's a clear distinction between the risky prompts and the normal benign prompts over the transformer layers. So robustness and variance tested on 100 bootstrap samples, so 80% resampling. So it is robust and variant proof. Efficiency and deployability, highly memory emission, only minor 34 MB peak to VRAM. Zero pre-training is required. It's like on the inference time we can use it. Trade-off is computing SRT layer by layer, roughly takes 20 seconds per prompt in our setup. So it is actually a little slow compared to other metrics or methods. So current limitation is that it's O of L into Z square, computational cost of the training, which is a little, which can be improved basically. And the framework is currently restricted and configured strictly for text modalities. So yeah, expanding the spectral framework for multimodal or vision language models and fusing our spectral features with gradient-based signals to further improve the discriminability of the sophisticated adversarial prompts. In conclusion, to conclude, we established a novel physics-inspired dynamic to system approach for LLM safety using Koopman observable space. Spectral properties successfully capture the non-linear dynamics, which is a really good thing. I mean, we did not expect that to perform really, really good in distinguishing the nonlinear prompts, adversarial prompts from benign prompts, because of the contractive and the dynamical nature of how LLMs produce the tokens and go transform it layer by layer. We can actually see, when linearized in an observable space, that there is a distinguishing properties available for that. Unlike black box classifier operating in the original transformer space, our spectral score offer interpretability, layer specific tracking, and vital robustness against iterative perturbations. I mean, we can, in each layer, we can see what is happening, why is it happening, and we can actually see which metric is being activated more for which prompts in which layer, which gives us more interpretability. It's basically interpreting in a mechanistic way using XAI, but more of a physics inspired and LLM infused system. Okay, thank you.
Okay. What is this Koopman observable space?
So
You are
kindly
not
switch on
audible.
your mic, please.
Okay, I'm sorry. So Koopman observable space is basically linearizing into a higher dimensional infinite space. So I mean, linear, if we have a nonlinear dynamical system, it is really hard to perform any metric or any system to know the next trajectory or next state of the system. Take, for example, the pendulum system. So it's a nonlinear dynamical system. It's really hard to really hard to know the next state which the system would append to. So with that, this theory emerged in 1930s by Dr. Koopman. So he proposed that any nonlinear dynamical system can be linearized into an infinite dimensional space, which is true as per fact. But thing is, we cannot actually, it's not possible to have a nonlinear dynamical or a lifted observable infinite lifted observable space. So what we do is we approximate that. So it's a set of functions which takes which transforms from normal state space to observable space in which it is linearized. Basically, coordinate transformation which is happening.
Okay. Okay. Thank you for the presentation.
Okay, thank you, sir.
Thank you so much for your presentation. Now I would like to call upon our next presenter for this session. Again, I would like to call upon Musdaq Zamani, sir, presenting a paper on the title Opportunities and Emerging Risks of Network Security Evolution through Artificial Intelligence and Machine Learning. I request you to kindly take over with your presentation.
Yeah, thank you. I share my screen, and hopefully this time the audio works.
So I can't see your screen as of yet right now. Yeah.
Hello, everyone. My name is Dr. Mazdak Zamani from Sunni Empire, the State University of New York. Today, I'll be discussing network opportunities and emerging risks and risks of network security evolution through artificial intelligence and machine learning. This talk explores how AI and machine learning are transforming network security, both strengthening defenses and introducing new risks. Let me begin with the big picture. Modern networks are becoming increasingly complex, and cyber threats are more sophisticated than ever, ranging from advanced persistent threats to AI-driven attacks. traditional security approaches, mainly rule-based and signature-based systems, are no longer sufficient to handle these evolving threats. AI and machine learning offer major advantages, including intelligent threat detection, automated responses, and even predictive defense capabilities. However, integrating AI also introduces new risks, such as adversarial attacks, privacy concerns, and algorithmic bias. So the key takeaway will be AI enhances security significantly, but it also creates new vulnerabilities. To adopt this effectively, we need strong governance, transparency, and robust model protection. So limitations of traditional network security. Before we dive into AI, let's understand why traditional systems fall short. Most conventional security mechanisms are deterministic and static. They rely on predefined rules and known attack signatures. For example, signature-based systems can detect known threats, but they fail against zero-day exploits, polymorphic malware, and encrypted traffic. So similarly, rule-based systems like firewall become difficult to manage at scale. Misconfigurations and rule conflicts are common. Another key issue is that these systems are reactive. They respond only after an attack has been observed. They also struggle with scalability and lack behavioral awareness, meaning they cannot effectively detect multi-stage attacks like lateral movements or botnets. So traditional approaches are rigid, reactive, and limited in modern environments. So that's the problem. AI-based detection models. Now let's look at how AI changes the game. AI-based network security systems follow a structured pipeline. First, data is collected from various sources like network traffic, logs, and endpoints, and then cleaned and normalized. Next comes feature engineering, where we extract meaningful attributes such as traffic patterns, packet statistics, and behavioral indicators. Then we train models ranging from traditional machine learning like random forest to deep learning models like LSTMs and graph neural networks. Once trained, these models operate in real time to detect malicious activity with low latency. When a threat is detected, automated response mechanisms can take action, such as blocking IPs or isolating compromised systems. Finally, these systems continuously learn through retraining to adapt to evolving threats. This creates a dynamic, intelligent, and proactive defense system. Emerging risks, adversarial machine learning. While AI improves detection, it also introduces a new attack surface. One major risk is data poisoning, where attackers inject malicious data into training sets to manipulate the model. Another is adversarial attacks, a small, subtle changes to input data that trick models into misclassifying malicious traffic as benign. There are also model extraction attacks where adversaries probe the system to reverse engineer how it works. In addition, AI systems can introduce privacy risks, especially when sensitive data is used for training. One promising mitigation approach is federated learning, which allows models to be trained collaboratively without sharing raw data. So while AI strengthens defense, it also requires us to rethink security at the model level. Evaluation and performance. Now let's briefly discuss how these AI systems are evaluated. So we typically use benchmark databases like what you can see on the slide. Models are trained and optimized using techniques like gradient descent and cross-validation. Performance is measured using metrics such as accuracy, precision, and a key practical concern is minimizing false positives, since too many alerts can overwhelm security teams. From a computational perspective, training can be resource intensive, but interface must be extremely fast, often under 5 milliseconds. Comparative results show that traditional systems perform poorly on new threats, while machine learning improves detection and deep learning, especially graph-based models, achieves the best performance for complex attacks. There is always a trade-off between accuracy, latency, and source usage. So in conclusion, I would say we are seeing a clear paradigm shift from static rule-based security to adaptive AI-driven systems. AI enables better detection of zero-day threats, reduce false positives, and allows real-time automated responses. However, it also introduces challenges like adversarial attacks, privacy risks, and the need for explainability. The core insight is this. AI enhances security, but also creates new attack surfaces. Looking at future research, we focus on robust and AI systems, privacy preserving learning, graph-based detection, and ultimately the future of cybersecurity depends on building intelligent, resilient, and secure AI systems. Thank you for your attention. I'll be happy to take any question.
Yes.
And also you can see.
Yes, sir. Actually, thank you for the presentation. Your presentation covers a lots of aspects of the network security and most of the parameters of like machine learning, AI, and configurations. Okay, so the question is actually, what is the objective of this presentation? Is that really to only explore the machine learning ideas into the AI or something else?
Yeah, as indicated in the second slide or third one, because it's the use of AI is evolving, and there are a lot of research addressing the advantages and the enhancement that we benefit from AI. But something that is
most of the time overlooked is the risk associated with the AI when it comes to analyze the logs and data from network.
Okay. Thank you, doctor. Thank you for the presentation.
Thank you very much.
Yes, organizer,
Thank you so
please.
much, sir. Yes, sir. Thank you so much, sir. Now I would like to call upon our next presenter for this session. Shrikavya Swarna, presenting a paper on the title Price Pulse, an AI-enhanced multi-platform price comparison system for e-commerce decision support. I request you to kindly take over with your presentation, please.
Good morning, ma'am. Good morning, everyone. I'm just sharing my screen. Is my screen is visible,
Yes.
ma'am?
Yes, your screen is visible now.
Yes, visible.
Yes, okay. Good morning, everyone, sir. Today I'm presenting this project named as the Price Pulse. It's a comprehensive multi-platform price comparison system for the quick decision support, sir. This project just focused on solving the real-world problem in online shopping just by helping users to compare the prices across the different multiple platforms, sir. So coming this, we have seen like with the rapid growth of this e-commerce platform, we are scrolling across the different platforms for use for selling the best price and also for getting the different prices, ratings, and just for same products we are just surfing against the different websites. So we are not coming as just currently users are manually visit these multiple websites just so by this, there will be more of time waste and also may leads to some missing some better offers. So existing tool doesn't have any comparison systems like this. So we have solved this by using AI powered insights that to take the best decision support. And also we have studied these studies in previous papers. Like these are the focus area like price comparison system and also multi-platform aggregation and also some web scraping and web application security and also database designs. Like in this they have implemented their techniques, but something they have limitations and gaps in those, but we have overcome those gaps in our paper and also we have implemented them by using AI powered with some SERP API and also some Gemini APIs. So the problem statement, it includes that users must manually compare the prices and ratings availability across the multiple platforms. So which is inefficient and also time consuming. So this was because of this users may overpay or they miss some better offers. So by this we have provided some unified systems like to integrate with some real world problems for the better price accuracy and also AI based some recommendations. So the methodology that we have used was it's a full stack web application using that Python, and front end we have used that React JS and also Next.js, and also for backend we have used some REST APIs using Flask, and for database we have used some SQLite for storing that fetched data by the users, and also we have integrated the Gemini API for the best insight generations related to that product. And external data source we have used the Google Shopping API, which is a SERP API, and for security just for logging in we are just using some JWT authentication. Overall the system collects and process and displays the product data in efficient manner. So this was the methodology, sir. When the user enters the search query on the search bar, then the front end that validates it and it sends the request to the backend. Then the API generates API request generates, and backend it validates and it sends the data to the front end. So this data was just processed using, we have used some algorithms. First, price normalizations. Actually, there are many prices across in different formats, but we have converted into one standard price format. And also we have used the product matching algorithms where when we want one product, then it searches that products overall all the platforms, so it matches the all products. So, and also coming to best product algorithms, we have used some which is giving the better ratings by the customers, and also low rate best price that is available on these platforms. So coming to this AI insight generation, in this while we searching for the product, it gives that we should buy and what's the important of that to buy that product, and it gives us insight generation for that our decision support that to sell or to buy that product. So this is the that I can show you the I can show you that overall this. So this is the website that we have built. So if we enter any product like as you like, or any MacBook or like anything, sir, like if we enter that product name, then if we will get that product from multiple websites, and also we'll get some AI generated recommendation based on this, and we can get some we can view on this product by using some we can view the ratings and reviews also, sir, by this. So this is the website that we have built on this, sir. So by this there are existing system that multi-platform comparison is very limited, sir. There is no multi-platform comparison also, and also there is no real-time pricing, and there is also no AI powered insights, and also there is no UI unified search, and also there is no security for that. So we have incorporated all these gaps from the existing systems, and also we have proposed this the Price Pulse website. So in conclusion, we have that successfully built this full stack web Price Pulse comparison website, sir. And we have also implemented this using some Gemini API and also SERP API. So the system will be secure and also responsive, and also some user friendly for the modern shopping challenges. So in future, we will incorporate some price alerts, and also mobile app integration, and also some other personalized recommendation basis systems, sir. So these are the references we have taken from the past papers and researches. So these are and thank you for this opportunity, sir. I would happy to answer any questions.
Okay, can you tell whether your study literature survey have considered the offers which are being provided by some cards or UPI transaction? Is that kind of analysis also being considered?
No, sir. We have doesn't consider any UPI based, sir. Just we have studies whether that price comparison system is there or not, and also is there any decision support for that to take some good some multi-platform aggregation that we have to consider.
Okay, thank you.
Yes, sir. Thank you, sir.
Thank you so much for your presentation.
Thank you, ma'am.
I would like to call upon again Sir Misdaq Zamani presenting a paper on the title Risks and Opportunities of Using Artificial Intelligence and Machine Learning for Digital Forensics. I request you, sir, to kindly take over with your presentation.
Yeah, thank you. I promise this is the last one. It's 18 minutes after midnight, so I try to be shorter on this one. Hello, everyone. Good morning or good evening here. My name is Dr. Mazdak Zamani. I'm an assistant professor of cybersecurity at Sony Empire, which is part of State University of New York system. And today I'll be presenting my work on risks and opportunities of using artificial intelligence and machine learning for digital forensics. This research explores how AI is transforming digital investigations, both in terms of capabilities and the new risks that it introduces. So, abstract. This study addresses a major challenge. Traditional digital forensic methods are no longer sufficient for modern environments like cloud systems, IoT, and encrypted communications. We propose an AI-enhanced forensic framework that integrates machine learning, deep learning, graph analytics, and explainable AI. Our results show significant improvements, up to 98 detection accuracy and 40 to 60% reduction in analyst workload. However, we also identify critical concerns, especially around explainability, adversarial attacks, and legal admissibility. Next slide will be about the literature review that we have done about evolution of digital forensics. So, digital forensics began with a strong focus on evidence recovery, change of custody, and structured investigation models. However, the field has shifted dramatically with the rise of cloud computing and IoT environments. These systems generate continuous, distributed, and highly dynamic data. Traditional disk-based and manual approaches simply don't scale anymore. Machine learning has been introduced, especially in intrusion detection, but challenges remain, including poor generalization and vulnerability to adversarial behavior. Also, continuing the literature review, AI in forensics and research gaps. AI has been applied across several forensic domains. In malware analysis, machine learning improves detection, especially for zero-day threats, but it can be evaded. In multimedia forensics, deep fakes created by GANs pose serious challenges, and detection models often fail on new techniques and technologies. Natural language processing, NLP, helps extract intelligence from text, but suffers from bias and domain limitations. A major issue is explainability. Tools like LIME and SHAP help, but black box models still raise legal concerns. research is fragmented and there is a clear need for integrated, explainable, and legally compliant frameworks. So modern digital environments introduce several key challenges. We are dealing with massive volume of data, often at petabyte scale. Cloud and IoT systems create distributed and volatile evidence sources. Encryption limits visibility while attackers use automated anti-forensics techniques. Additionally, AI-generated media like deepfakes introduces entirely new forms of synthetic evidence. These pressures are driving the adoption of AI, but also increasing complexity and risk. AI across the digital forensics lifestyle. Rather than replacing traditional forensic processes, AI enhances each stage of the lifestyle. For example, in identification, AI enables anomaly detection. In collection, it supports selective acquisition. In examination, it automates triage. In analysis, it uses graph-based learning. And also in reporting, it provides explainable outputs. This integration ensures we maintain forensic soundness while improving efficiency and scalability. AI-enhanced digital forensic architecture. And here we propose a 6-layer architecture that combines technical processing with governance. The layers include data acquisition, preservation, AI processing, correlation, explainability, and reporting. A key contribution is embedding explainability using tools like what we have and mentioned here directly into the architecture. This helps address legal concerns around transparency and admissibility. Experimental methodology. To evaluate our approach, we tested AI models across 4 domains: network intrusion detection, malware classification, multimedia forensics, and text analysis. We used well-known data sets and also statistical validations, or validation included effect size, analysis that you can see on this slide and the table. So in conclusion, I would say that AI offers substantial benefits for digital forensics, including improved detection accuracy, scalability, and efficiency. However, it also introduces critical challenges like adversarial vulnerabilities, lack of interpretability, and legal and compliance concerns. Our future research would focus on making AI systems more robust, explainable, and aligned with legal standards to ensure they support judicial integrity. Thank you for your attention, and I will be happy to take any question.
Yes, sir. Can you just elaborate which are the forensic tools you have been referred for this your work?
Yeah, in the traditional way, we usually use the tools that even not in only for the academic way, but also for like private sector or even FBI. Some tools like OS forensics are used, but when it comes to some data that are stored on cloud computing, on cloud, then most of the application are based on the if we use ChatGPT, we use the GPTs to see how they can detect the, for example, the tamper on the images, and that raises the problem of explainability. They just return the yes or no without providing the proof and the procedure that is required for legal applications.
Thank you, sir.
Yeah, thank you.
Thank you so much, sir. Now I would like to call upon our last presenter of this session, Sanjida Karim Pioli, presenting a paper on the title, A Comparative Study of Machine Learning Models for Early Diabetes Risk Prediction. I request you to kindly take over with your presentation, please. Ma'am Sanjida.
Good morning, everyone.
Good morning.
Can you see my screen?
Yes, ma'am, we can see your screen.
Good morning, I am Sanjida Karim Pioli, and today I will present my research on early stage diabetes risk prediction using machine learning and static ensemble. Problem statement. Diabetes is a major global health problem. Early detection in challenging. In many cases, proper diagnosis depends on laboratory tests like HbA1c, glucose, which are not always available in resources. Existing machine learning studies have achieved high accuracy, but they often use a small dataset lag generalization and limited interpretability. So there is a clear need for a more reliable interpretable prediction model. Objective. The main objective of the research is to develop an accurate and interpretable machine learning models for early stage diabetes prediction we use a symptom based data set which 1560 instances. Our goal is to improve prediction accuracy, ensure better generalization and enhance clinical interpretability so that the model can be useful in real world healthcare application. Research gap, related work and research gap. In previous studies, most of researchers use dataset like UCI and PIMA. Commonly used models include random forest, KNN, SVM, and XGBoost. These models achieve very high accuracy, often between 97 to 99%, and ensemble methods further improvement performance. However, several clinical gaps are existing model studies relay external validation, and many models lack biochemical features like HbA1c and glucose. Also, explainable AI techniques are rarely used, which reduce clinical trust. To address these issues, our work uses a reliable larger dataset, applies systematic hyperparameter tuning, and develops a stacking ensemble with features importance analysis for better interpretability. dataset, we use the early stage diabetes dataset collected from Kaggle, which contains 1560 instances. There are 16 predictor features and one target variable names diabetes risks. The predictor includes demographic features like age, gender, along with several clinical symptoms like polyuria means frequent urination, polydipsia means excessive thirst, polyphagia means excessive hunger, genital thirst means fungal infection, visual blurring means unclear vision, and many things. The target variable indicates diabetes risk, where 1 represents high risk and 0 represents low risk. EDA and correlation analysis. Before model in training, we performed exploratory data analysis. We found that there were no missing values in the datasets. Categorical features were encoded into numerical format. We also generated a correlation heat map to analyze relationship between features and the target variable. The heat map shows the symptoms like polyuria, polydipsia, and weight loss have a strong correlation with diabetes risk. This helps improve interpretability and supports our model finding. Methodology and experimental setup. Our methodology starts with data pre-processing. Then we trained 6 machine learning models like logistic regression, decision tree, random forest, KNN, naive Bayes, and XGBoost. After that, we applied hyperparameter tuning using grid search CV. We also developed a stacking ensemble model. Finally, we evaluate the model using multiple metrics such as accuracy, precision, recall, F1 score, and ROC AOC curve. For experimental setup, we used 80% for trained and 20% for test, and 5k-fold cross validation to ensure reliable result. Baseline result. In baseline result, XBoost achieved the highest accuracy of 94.87%. Random forest followed with 93.27%. Logistic regression, decision tree, and naive Bayes achieved the around 90% accuracy, while KNN had the lowest performance at 89.10%. In terms of metrics, XGBoost showed the highest recall and F1 score, while Random Forest and XGBoost had the highest ROC AOC values around 0.99. This result indicate the ensemble-based models perform better than individual model. Confusion matrix and ROC AOC. To further evaluate model performance, we analyze confusion matrix and ROC AOC curves. Confusion matrix show correct and incorrect prediction. XGBoost had the lowest misclassification, followed by Random Forest. KNN and decision tree showed the comparatively more errors. In ROC AOC analysis, XGBoost and Random Forest achieved the around 0.99, indicate excellent classification performance. Other models also perform well with AOC values above 0.96. Hyperparameter tuning. After applying hyperparameter tuning, all models showed improvement. For example, logistic regression improved from 90.38% to 92.23%, and random forest improved to 93.27% to 94.55%. Then XGBoost improved 94.87% to 95.03%. This shows the accuracy. This shows that tuning helps reduce overfitting and improve generalization. Feature importance. To improve interpretability, we analyzed feature importance using XGBoost. The most important feature were polydipsia, polyuria, gender, and irritability, and partial paresis. Some features like muscle stiffness and visual blurring had lower importance. These results are consistent with clinical knowledge and help in understanding the key risk factor. Staking ensemble. We developed a staking ensemble model using logistic regression, random forest, and XGBoost as base models. Logistic regression was used as the meta classifier. The model achieved the highest accuracy of 95.19%. This confirms that combining multiple models improve stability and overall performance. Limitation, future work, and conclusion. Despite of good performance, there are some limitations. The dataset is relatively small and based on self-reported symptoms. There is no external validation and no biochemical features like HbA1c are included. In future work, we plan to use larger and real clinical datasets, include laboratory features, and apply advanced explainable AI techniques such as shape and lime. We also aim for real-world deployment in healthcare system. In conclusion, the proposed model improves early stage diabetes prediction, ensemble learning, enhance performance, and feature analysis, improve interpretability. This model can be useful for clinical decision support system. Thank you.
Am I audible?
Yes, sir.
Okay. So what was the primary objective of this your work?
Our primary objective is our work is was to develop an accurate and reliable machine learning model for early prediction of diabetes based on patient symptom and medical data.
So as per this medical symptoms, so which are the number of symptoms you have considered for your research work?
There are 1,560 datasets where 16 are features and one target value named diabetes risk.
Okay, thank you.
Thank you, sir.
Thank you so much for your presentation, ma'am. With this, we come to the end of our session. I sincerely thank all our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope the session was informative enough. We, on behalf of the whole team, thank you for your support during this 11th version and all the previous 10 versions of this conference. We will be happy to have you in the 12th version in 2027. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICTIS 2026. I also would like to thank our session chair, Dr. Manoj. Sir, I'd like to present a token of appreciation from the team on the screen. Thank you so much for being the session chair for this session, sir. I would like to ask you if you have any closing remarks from your end for our participants today. Sir? Okay. Now I would like to request all of you all to kindly switch on to your cameras for a quick snapshot of this virtual session we just attended. Requesting all to kindly switch on to your cameras, please. Requesting all of you all to kindly please switch on to your cameras so that we can have a quick snapshot of this session. All presenters, participants, I request you all to please switch on to your cameras for a quick snapshot. Thank you so much. Now all of y'all can exit. Thank you so much for the session. Thank you.
Yes, thank you also. Bye.
Thank you.
Shall I leave, ma'am?
Yes, sir. Yes, sir.
Yeah. Thank you all.
Thank you
Thank
so
you,
much.
the host and all the participants. Thank you.